Hello again, and we're going to continue with our graphing series. And if you watched the previous video, you know that I just went over properties of graphing. And properties of graphing basically go into the calculating the slope, where to find the slope, how to calculate and create the equation of a line, and we'll go into that today because the properties I went over in the previous video was mainly for students that are just getting into graphing, and today is the second part, which goes into the rest of graphing, which is the methods. And here I am going into method one. Now again, I teach a little bit differently, and I will, show you what the directions will be, when the directions on a homework or directions on a test. It won't be plotting points, or it won't be method one. This method will be called graph using ordered pairs, graph using coordinates, graph using points. So I'm going to highlight this, and this is what the directions will ask for. It'll ask for graph using ordered pairs, graph using coordinates, or graph using points. So if you see the directions, and the directions say graph using points, graph using ordered pairs, or graph using coordinates, you need to use this method. Now let me go ahead and explain something to you about some of the computer programs out there and how they do things. One of the reasons we teach different methods of graphing is for different types of graphs. For instance, this method is used when graphing a straight line, but it's also for nonlinear. And that's going to be helpful to you, especially if you go on into college algebra and calculus. So you need to learn this method, not only just for graphing a line, but you also need it for later on when you're doing parabolas and hyperbolas and things like that. First of all, when do you use this method? Well, usually you use it when y is by itself. Y is by itself. Now, you can use method 3, and we'll go over that in a little bit when y is by itself. But in this case, you can use method 1 or method 3 pertaining to what the directions are saying. If the directions say just graph, then you can use any method you want. If the directions say graph using ordered pairs, points, or coordinates, you have to use this method. If you use a separate method, you may get the problem wrong even though you graphed the line correctly. Okay, so that's one of the things with these computer programs like MyLabs Plus and MyMathLab. They expect for you to plot the points that you get with the method 1, method 2, or method 3. And if you don't plot those points, then you could get the problem wrong. So what do you do first? Well, you make sure that y is by itself. In other words, you make sure you solve for y. Now, for those of you that have just taken the pre-algebra and you remember, a linear function or a linear equation has both x and y in them. So you have to be careful when you're not solving, you're solving for y. Okay? And let's move on down. And I'm going to move this over a little bit. After you solve for y, you create a table. Now, why do I pick those 5 points? Well, there's several reasons. I picked those 5 points because they're both on the left and the right-hand side of 0 on the number line. They're small numbers. and there's at least 5, so therefore if I mess up one, I got 4 others to take up with it. Now people with lazy disorder, they don't like to use 5 points. Another reason I use 5 points is when you're in a nonlinear situation, which means a curve, you need to at least graph 5 points. At least. So again, we're not just training for drawing a straight line, we're training for lines and curves. So remember, this method, method 1, plotting points, is not only for linear, it's for nonlinear for other math classes. 90% of the time, I'm going to use -2, -1, 0, 1, and 2. If you come into my office and ask me, Hubert, graph this line, I'm going to use, if it's not a fraction, I'm going to use -2, -1, 0, 1, and 2. Unless the application tells me to use other numbers, I'm going to use those 5 numbers. If you come into my office 10 years from now, 3 years from now, or 20 years from now, I am going to use those 5 points. Why? Again, 5 points, they're small numbers. You got negative, 0, and positive. And it's easy math. 10% of the time, I'm going to use multiples of the denominator. Well, what does that mean, Hubert? Well, on the next page, I give you examples, and it's sideways. And I don't know if I could flip this around. Hold on, let me see. I don't think I can flip it around, but I'll try. Well, I thought you could. I thought there was somewhere on here you could actually flip it, but I'm not going to worry about it right now. I guess not. I thought for sure you could actually flip it. Let me see if there's. No. Oh well. Anyway, you have this handout. You'll have this handout if I, pass it out, and you can see that. I thought for sure you could flip these things. But anyway, I'm going to go to the far left of the page. Down here, I've got 1/2 plus 4, 1/2 x plus 4. I'm going to use multiples of 2. Y equals 1/3 x minus 2. I'm going to use multiples of 3. Over here, I've got 1/6 x minus 1. I'm going to use multiples of 6. And here, I've got 1/7. I'm going to use multiples of 7. And again, that's not, you don't have to do that, but the reason I do it is because it clears the fraction. So that's something just added to you, added for you to, if you are given a fraction, use multiples of the denominator. And I think we have a example that we can do. Okay, we don't have an example. I thought we did have an example. Okay, well, what I'll do is we'll do an example. So let's go to our handy dandy whiteboard and let's pull in a handy dandy graph. There we go. And let's go ahead and do a problem. So y is equal to 2x minus 3. Okay, and I'm going to draw, it's already solved for y. So I'm going to just go ahead and draw my chart or my table, whatever you want to call it. Now, since this is not a fraction, I'm going to use -2, -1, 0, 1, and 2. Now I'm going to plug in the numbers. 2 parentheses minus 3. 2 parentheses minus 3, 2 parentheses minus 3, 2 parentheses minus 3, 2 parentheses minus 3. And I'm going to do this because I want to color these blue. We're going to take those blue numbers and we're going to plug them in right here. And that is our formula, 2x minus 3. That's where that comes from. And now I'm just going to do the math. And whatever we get for an answer, that is our y. So, -4 minus 3 is -7. -2 minus 3 is -5. 0 minus 3 is -3. And you can see we're adding 2. So this one's probably going to be -1. And if we add 2 to -1, we get 1. And let's check that last one. 4 minus 3 is 1. This right here, I don't know why it does that, but let me hit undo. There. Over here is the domain of the function. Domain is a 25-cent word for input. Now, could we plug in more? Yes, we could plug in anything. But just for what we're drawing, our domain is from -2 to +2. If you had -5 to +5, the domain would be -5 to +5. Domain is dictated by the problem sometimes, if it's a radical or irrational. Sometimes it's dictated by the instructions of the problem. Sometimes it's dictated by the instructor. Okay? And this domain gives us this range. Range is a 25-cent word for output. So now we're ready to graph this line. So I'm going to take my handy-dandy straight edge. That's good enough for government work. And since we used blue, I'm going to use blue as a marker. -2, -7. -2, 1, 2, 3, 4, 5, 6, 7. -1, -5. -1. 0, -3. 1, -1. And 2, +1. And if you'll look, all 5 of those lines, all 5 of those points make a straight line. Of course, mine's off a little bit, so I'll move it as soon as I... There we go. And there's your line. Now, just for this problem, just for this area right here, and I'll highlight yellow, just for this part right here, that's these 5 points right here. So that's what I meant by the domain and range. The domain is, and I'll do that in green, the domain is -2 to +2. And the range, and we'll do that aqua color, is from -7 to +1, just for that chart. Of course, this problem dictates that you can plug in any number you want to, so it gets a arrow on the end and an arrow on the end, because this function, you can plug any number you want to into this function. You can plug in fractions, decimals, percents, negatives, positive, so it gets arrows on the end of it. Okay? And that is a linear equation done by method 1, which is graphed by plotting points, coordinates, or ordered pairs. So let's do one now with a fraction. Y is equal to -1/3 x plus 2. And of course, first thing I do, since y is already solved, I don't know why I wrote a 2 there. I guess I hadn't finished my coffee yet. And y And I'm also, just as soon as I do that, -6, -3, 0, 3, and 6. Why? Because now I have a fraction. And I'm going to use multiples of 3, which would be -6, -3, 0, 3, and 6. Now, I'm going to plug in my numbers, and I'm going to color them blue again. And I'm going to -1/3 parentheses plus 2, -1/3 parentheses plus 2, -1/3 parentheses plus 2, -1/3 parentheses plus 2, -1/3 parentheses plus 2. Now, a lot of people saying, golly, you have to write all that? Remember, this is a review. I am an instructor reviewing over material that you have forgotten. Okay? What you do with that material after it comes back to memory, that's up to you. This is how I show students that have never seen the material before. After you go through it, you're going to say, oh yeah, I remember that. Well, I could just do -6 divided by 3, -3, -3 divided. I can do it in my head. Well, that's fine. Just don't get mad if you get it wrong because you made a careless mistake. So here we go. And I'm going to make these into fractions. -6 over 1, -3 over 1, 0, 3 over 1, and 6 over 1. And the reason I made them fractions is because I have a fraction in front of it, so I'm going to just make it easy on myself. And now we can do our math. What's -6 divided by -3? 2. 2 plus 2 is 4. -3, sorry, I don't know why it does that. -3 times -3, -3 over -3 is +1. 1 plus 2 is 3. Looks like we're subtracting 1, but let's check the next one. 0 plus 2 is 2, so we are subtracting 1. So 4, 3, 2, 1, and 0. -6 divided by 3 is -2. -2 plus 2 is 0. So it does check. Let's take our handy dandy straight line maker and let's draw an y-axis and an x-axis. And plot these blue points. So -6, +4. -6, +4. -3, +3. 0, 2, 3, 1, and 6, 0. And if you look, you have a straight line. Now, let's talk about domain and range again. Well, in our little box area right here, in just this little area that I created, the domain is -6 to +6. So I would just draw yellow, -6 to +6. There's my domain. But that's just in that little area. Okay, that little yellow area, that box that I just drew over there. All right, so my range is from 0 to 4. So from 0 to 4 is my range. Now that's just in that little yellow box. This one does get arrows again because you can plug any number into this equation. and we'll get into this when we get into functions and we talk about domain and range. We'll get into it a little bit more in depth. But unless you have a radical in your equation, or a log, or a fraction, unless you have one of these, the domain most of the time is going to be all real numbers, which is arrows on both ends. But we'll get into that later with functions. So that's method 1. So let's go back and look at method 2. Method 2 sorry about that. There we go. Method 2. When do you use method 2? Well, when the directions say graph using intercepts. That's when you're going to use method 2. Okay, the directions will tell you graph using the intercepts. Graph using the x and y intercepts. If you see those words in the directions, you have to use this formula. This method. Okay? That's pretty simple. And if you don't graph the x and y intercepts, then you will get the problem wrong. So either way, no matter which method you decide to use, you will have to graph the x and y intercepts. If you don't graph the x and y intercepts, the computer or the software that you're using will mark it wrong, even if you draw the correct line. And I say that to my classes over and over and over, and I still have students that will not use the correct method. And they get it wrong, and then they come to me and say, well, Hubert, can I get credit? No, because I told you 3 or 4 times that you have to use the method that I give you, or that is given. All right, what do you do? Well, let's go ahead and do an example while we're doing it. 2x plus 3y is equal to 6. There's our example. Now, what do? You draw a big table, just like I just drew right there, and I label it with the x-intercept, and I highlight the 0 for y, and then the y-intercept, 0 for x. Now, one of the reasons I do this is not because just teaching you how to draw a line. I don't care if you're in marketing. I don't care if you're in business. I don't care if you're in management. I don't care if you're in economics. I don't care if you're in chemistry, physics, or biology. Any graph that's thrown in front of you, if you want to find the x-intercept, you plug in 0 for y. If you want to find the y-intercept, you plug in 0 for x. So, am I showing you this because you need to learn it because of my test? No. I'm showing you this because in any graphing application, in any college, any branch of study, any class, if you've got a graph in front of you and you want to find the x-intercept, you plug in 0 for y into the function. If you want to plug in get the y-intercept, you plug in 0 for x. So you need to put that to memory, not because of this class, but because of 5 or 6 other classes that you may be taking in the future. So, with that being said, I'm going to take my problem and I'm going to put it right up under here. Oops. I don't want to write that in red. I don't like writing in red. 2x plus 3y is equal to 6. 2x plus 3y is equal to 6. And at this point, you notice something. What do you notice about the way I wrote those under the highlighted 0? All you got to do is just drop that 0 down and plug in for y. drop that 0 down, and plug in for x. Now, there are some teachers and some students that just cover it up with their pencil. Cover up that 3y and solve. Cover up that 2x and solve. Again, that's what you do when you have remembered how to do it. I'm not teaching you shortcuts before you learn how to do it. I'm teaching you how to do it, and then you develop your own shortcuts. So, with that being said, 2x plus 3 times 0 is equal to 6. And of course, that 0 goes out, which that means you cover it up with your pencil, or you erase it, or whatever you want to do. I don't care. 2x is equal to 6. X is equal to 3. And that 3 goes right there. And now you do the same thing with the other side. We take that 0 and plug it in. Plus 3y is equal to 6. That 0 goes out. You're left with 3y is equal to 6. I don't know why I wrote 2 there. 3y is equal to 6 divided by 3. Now I know why I wrote the 2 there. Y is equal to 2. And that 2 goes right there. And now you plot those 2 points. So I'm going to go up here. Well, I don't know. Yeah, I'm going to go up here. And since I don't want to go between applications, so I'm just going to draw a line because I want to show you something. I'm going to roughly draw this graph. Now, another reason I put the x-intercept word up here is because the number one mistake students make on these problems, whether it be homework or a test, they plot the wrong point. I bet they plot the point on the wrong axis. So that's why I put the word up here. So you won't plot on the wrong axis. Okay, that's why I put this word here. And I put this word here. So you know this goes on the y-axis and this goes on the x-axis. There's reasons I do things. Okay, so 3, 0 on the x-axis. 0, 2 on the y-axis. And here is my line. Now, how do I do a check on this one? Because the first method, you actually have 3 other points to check your math. This one, you don't have but 2, and it only takes 1 to mess it up. So what I do is I make x, this is your check, I make x equal to 1 and calculate for y. And then see if that point hits my graph. So let's do that. 2 times 1 plus 3y is equal to 6. Subtract 2, 3y is equal to 4. Y is equal to 3/4. So if I plot 1 and 3/4, I should hit that line. Well, mine's a little bit off, but you can't go by my graph because I don't have any graph paper behind it, so I'm a little bit off. So that point right there should be 1, 3/4, and that's your check. If you do this on a piece of graph paper, you should hit 1 and 3/4. And that's how you do method 2. Again, you probably are saying to yourself, oh yeah, I remember that now. We did that. Yeah, I remember that. Well, that's method 2. What's method 3? Well, method 3 is probably the most well-known. Why? Because you don't really have to do any math, and that's why students like it, and that's why teachers teach it. There's an example. There's one right there that we... Method 3 is called building a line. When do you use building a line? When it says graph using intercept, y-intercept, and slope. That's what the directions will say when you're given that directions on a homework or a test. It'll have intercept and slope. It doesn't say intercepts. Okay, it's not plural. And it doesn't say x and y intercept. It says intercept and slope. Now, when you use it, you can use it like method 1, when y is by itself, method 1 also. But I like to tell students that I use, when I don't have to use a certain method, I use when the slope is a fraction. That way I don't have to put multiples of the denominator. But that's only when the directions say graph. When the directions say graph, and I've already said this 2 or 3 times, when the directions just say graph, you can use any method you want. Okay? So, what do I do first? I get y by itself, and you know that. That's from method 1. Get y by itself, then what? Then, you extract information. What do I mean, Hubert? Well, you know from the first video we talked about, y is equal to mx plus b. You know that this, and I highlighted that in, this is your y-intercept. You know that this is the direction of the slope, whatever that sign is. And you know that this is vertical over horizontal. And that's what I just wrote down right there. So you don't have to do any math. All you have to do is look at let me give you an example. Y is equal to 2x plus 3. I'm going to do 2 examples. I'm not going to draw them. I'm not going to graph them. I'm just going to go through and get the information. 0, 3. I got a positive slope, meaning my trace line is going left to right up. And 2 over 1 is my vertical over horizontal. So that's how you do it. I'm not talking about graphing. That's how you extract the information. So here's another one. I'm going to leave that up. 1, 2, 3, 4, 5. You should have paused the video so you can rewrite it. Now let's do another one. Y is equal to negative 1/4 x minus 2. My y-intercept is 0, negative 2. My slope is negative, meaning left to right down, and 1 over 4 is my vertical over horizontal. Now, I will admit that there's some students and some teachers that include the sign with the negative, with the 1/4 down at the bottom. I do not do that because I try to teach all my students that there's the negative and positive only tells us the direction. And I try not to include it with my 1/4 because 1 over 4 technically is distance, and distance can never be negative or positive. And I'm a stickler about that because I don't think negative and positive should be associated with anything having to do with distance, because that confuses students. Okay, so what does 3 say? Plot y-intercept. So I'm going to just go down here and I'm going to erase this. And I'm going to go down and plot trace line lightly, and here we go. Here's an example. Y is equal to 3x plus 6. Y is equal to 3x plus 6. So 0, 6 is our 0, 6 is our y-intercept. And we have a positive right here, so that means left to right increasing. and 3 over 1. And that's pretty much it. Plot my y-intercept, 0, 6. My trace line is left to right up. You can do that with a real light line. You can just take your pencil and just draw it, or just put your pencil up on the monitor and say, okay, it's going left to right up. So now vertical, 3 up, 1 over, 3 down, 1 over, and your line is going like that. Once you draw your line, you can erase your trace line. So I want to go over one of these on the graph paper that I have, because I think it's important to go over this one with graph paper, because you really can't do it without graph paper on method 1 or, well, all 3 of them. It's kind of nice to have graph paper. So let's go ahead and do that. All right, so I'm going to make up a problem. Y is equal to negative 1/2 x minus 3. So 0, negative 3. My negative tells me that I'm going in the left to right down. So that's my trace line. And then 1 over 2 is my vertical over horizontal. So I draw my handy dandy vertical axis and horizontal axis. I plot my point. So I'm gonna make this, I'm gonna highlight that negative 3 right there, negative 3, and I'm gonna put a dot at negative 3. There we go. So there's my y-intercept. And I'm going to use a highlighter and a real light yellow line. And that's going to be that right there. And I'm just going to draw a line like that. Boom. I don't even know if it's straight or not. Why? Because it really doesn't matter, because all you're using it for is a guide. And then I'm going to take a green marker, and I'm going to do vertical over horizontal. I don't care which way you go, up or down, it doesn't matter. You just have to go along with the trace line. So I'm going to go up because that's negative, and students say, oh, you have to go down. No, I'm going up. So up 1, boop, and over 3, 1, 2. Now why did I go to the left? Because my trace line's over there. Go down 1. 1, 2, with trace lines over here. Go up 1, 2, 1, 2, 1, 2, 1, 2. And you just built a line. And you can erase your trace line after that. And there is your line. And that's how you build a line. And a lot of people do this method, especially when y is by itself, because they don't have to do hardly any math. But remember, when it says graph by itself, just graph, it'll either say use any method or it'll just say graph. That's when you can use any method. When it just says graph or it says graph using any method. Okay, so I'm going to write those both up here. Graph or graph using any method. That's the only time you can use any method. Any other time, it's going to say graph using points, coordinates, or ordered pairs. Graph using the x and y intercepts, or graph using intercepts, plural, or graph using the intercept and slope, or slope and intercept, singular intercept. So that's how you do the 3 methods of graphing. The only one that you can do nonlinear is method 1. Okay? So let's look at the last page, and we went over this before, but I want to go over it for a reason. We went over this in the last video, and it is more of an introductory, and I'm not going to go over the first part of this because you've already seen it in the previous video. But again, that's pretty pre-algebra right there. We went over this just now. We just went over that. We also went over that in the previous video. We went over the slope formula. And I want to put that on the board just for a second so you can write down if you missed it in the last video. I don't understand why you would miss it. But there is the point slope equation. I meant the slope equation. The point slope equation is what we're going to go over here in just a second, because I did not go over it in the previous video because it was more of an introduction. So I went over this one. I showed you how to use it. I think we used one of these points right here. I think we used this one. I think we used this point right there when we did the problem. Yeah, I think we did, because you got 6, I think it was 3 halves, I think, in the previous. So another one you could try this one and find the slope of that one. Or we might use that one for the next problem. I think we'll do that. We'll use that one to show you how to find the equation. Because these 3 problems right here are also problems to find an equation. Okay, that's what the directions will say. Find an equation. This one will say calculate the slope. So I'm showing you what 2 problems you will see. Calculate the slope and find an equation. Those are the 2 sets of directions that you might see pertaining to Algebra 1 material. So we're going to use those 2 points. I'm going to go to the whiteboard, and we're going to graph those 2 points because I want to show you what we're actually doing. So I'm going to go ahead and plot those 2 points first. I think one was 4, 0. 1, 2, 3, 4. And, or sorry, 4, 0 and 0, 4. I think it looks something like that. And they will give you the 2 points somehow, or you got to find them. But that's not a big deal, because usually if you can see the 2 points, that's what you're going to pick. All right, there's the 2 points. Now, the question is, find the equation of that line. That's going to be the question, and the directions will have this right there, and it'll say, or it'll have 2 points, and it'll say, find the equation of the line. And this is 0, 4, and this is 4, 0. So we read from left to right. So this is x of 1, y sub 1. This is x sub 2, y sub 2. So we've got to find our slope first, because to use the point slope equation, point slope equation, you've got to have a point and a slope. So slope is equal to y sub 2 minus y sub 1 over x sub 2 minus x sub 1, which is equal to parentheses minus parentheses over parentheses minus parentheses. And I do that. And I've got several degrees, and if you walk into my office 10 years from now
and asks me to find the slope of a line, I will use those parentheses. Of course, we have people that do not have degrees that don't need those. Yeah. Anyway, when you have decimals, when you have fractions, when you have positives or negatives, those parentheses come out very handy. So, what is y sub 2? Y sub 2 is 0. Y sub 1 is 4. X sub 2 is 4. X sub 1 is 0. And of course we get 4 over 4, negative 4 over 4, which is equal to negative 1. So negative 1 is our slope. So now we pick a point. I don't care which point you pick. You can pick either one. You need a point. So I'm going to pick 4 and 0. And the slope is equal to negative 1. So we have our point and our slope. So what is the point-slope equation? Y minus y sub 1 is equal to m times x minus x sub 1. That's the point-slope equation. So we read from left to right. So this is x sub 1, and this is y sub 1. So y minus parentheses is equal to parentheses times x minus parentheses. X sub 1 is 4, negative 1, and y sub 1 is 0. Y minus 0 is y. Negative 1x plus what? 4. So your equation is y is equal to negative x plus 4, and that is the equation for this line. Y is equal to negative x plus 4. And that's how you find the equation of a line. So, you need to know the 3 methods of graphing. You need to know how to plot points. And you need to know how to calculate the slope and find the equation of a line. Now, there's one other thing that you need to remember, which I showed you in the previous video, and that is parallel lines. Right there. When x is equal to a number, it's parallel to y. When y is equal to a number, it's parallel to x. And you just need to remember that. I gave it to you in the previous video. Now, when we do Algebra 2 review, we will throw in parallel and perpendicular lines as far as finding the equation of a parallel and perpendicular line. I'll go ahead and show it to you. I'm trying to get all of that on one screen, but it's not helping me out. So there. And of course, you should have this as a handout, so you don't have to rewrite it. But for those of you that don't have a handout, you can rewrite it.
You have a work email.
And let's make that go down. Here is what I wanted to show you, and this is what we go over in Algebra 2 review, and that's the next series of videos we're going to do. If two lines have equal slopes, they are parallel. If two lines have reciprocal slopes with opposite signs, the lines are perpendicular. So that might be something you might want to write down for the future, and you can use that. And we do go over that in Algebra 2 or Math 102 here at Tri-County. And that should take care of the graphing for Algebra 1 review.